you. So today we will be discussing some problems which probability theory what we have discussed in the last two classes, last three lectures in fact, one lecture on tutorial, and we have discussed probabilities on two lectures. Now in the last lecture we have discussed probability on conditional probability and the total probability. Today we will be doing tutorial on those topics. So I'll also solve, we'll see some objective type questions, and mainly we'll be doing some problems which will really help in building your problem solving aptitude. So now first objective type question. It's a very simple objective type question, all of you will be able to answer. Just see very carefully. What it is given is, even A and B are mutually exclusive, determine which of the following relations are true and which are false. First one is given that A and B are mutually exclusive. So if A and B are mutually exclusive, so then what is the first question, that is A, what it is given, probability of A given B, it is equals to probability A it is given. So it is true or false. What it is telling that even B has occurred, what is the probability that A has occurred? Now since A and B are mutually exclusive, what will be the probability of A given B? It will be definitely, it will be 0, it will not be probability A, right? So it is false. Now coming to the second one, what it is given, probability of A given B by probability of B is equals to probability of B given A by probability of A. So I think now you will be able to answer this question what it will be, because probability of A given B, that is 0, 0 by PB is definitely 0, the right hand side also it is 0, so this is true. Then a third question what it is, probability of A intersection B is equals to probability of A into probability of B. Again mutually exclusive events, we have seen probability of A intersection B is 0, right? So this is false. Now we will see under condition of independence, if the even A and B are independent, okay, then under that condition the probability of A given B is also probability of A. It is true or false? Of course it is true, right? Under condition of independence, it does not affect whether the even B has occurred or not. So probability of A given B is probability of A. Then what is probability of A given B upon probability of B? Is it equals to probability of B given A by probability of A? That you will be able to do it by yourself, and that is obviously that is false. Okay. Next is probability of A intersection B. Probability of A intersection B is also probability of A into probability of B. That is true in case of independent event, right? Second questions. Two events A and B are independent if and only if probability of B given A is P of B and probability of A given B is probability of A. Is it correct? Obviously that is correct, right? So it's a very simple questions. Now we will be solving some big problems which will really help you to understand the concept of conditional probability as well as the total probability. First question. For married couples living in a certain suburbs, the probability that the husband will vote on a bond referendum is 0.21. The probability that the wife will vote on the referendum is 0.28, and the probability that both the husband and wife will vote is 0.15. So what is the probability that A, at least one member of a married couple will vote? Now the question is that here in my last tutorial I have also mentioned that whenever any probability problem, always first try to write down the events. If you write down the events, then solving it will become very easier. You will be able to picture it actually clearly. So now what is it? So see here the Venn diagram. From the Venn diagram it will be clear, because what it is given, the probability that the husband will vote, that is the, okay, let me show it through a pen. Okay, this portion, this whole portion, okay, this whole portion is the probability that the husband will vote, right? And the probability that the wife will vote is the other portion, this is the W, this circle, okay. Now and what it is given, probability that the wife and probability that both the husband and wife will vote. Both of them will vote means that is the intersection part, right? So which one is the intersection part? The slight pink, this one is the intersection part, okay. So all these probabilities are given. So this is given to us, probability of H is given, probability of W is given, probability of H intersection W. Both husband and wife will vote, that is H intersection W, and both is independent, right? So now what it is given, what is the probability that at least one member of married couple will vote? At least one member means what we need to find out? At least one member means either husband will vote or wife will vote or both will vote, at least one. Okay, at least one means it is union. So it is probability of H union W. So what is probability of H union W? We know the formula, probability of H plus probability of W, and we will have to subtract the H intersection W part. Remember why we have subtracted it? Because we have calculated that part twice. Once while we have calculated it for H, we have taken that part. Again when we have done for W, we have taken that part. So we have taken that part twice. So we have to subtract it once. So this probability of H intersection W, H union W, as we will be doing by using this formula, right? Then next question. A wife will vote given that the husband will vote. A wife will vote given that the husband will vote. So what is that means what? Given that the husband will. That means probability of W given H. So probability of W given H. What is probability of W given H? Probability of H intersection W by probability of H. Probability of H intersection W is given to us. Probability of H is given. So we'll be able to solve it, right? So now then. Similarly, the next question, a husband will vote given that his wife will not vote. See here, the third is a bit complicated, not very complicated if you draw the Venn diagram. So always write down the events and then draw the Venn diagram, then things will become very clear. Now from the picture you can understand, it is given a husband will vote given that the wife will not vote. So husband will vote in this picture is the circle of H, right? This is the circle for H where husband will vote, and this portion, this light pink portion, this is the portion where both the husband and wife will vote. Now it is given that the wife will not vote. That means from the husband part, from this whole circle, we will have to subtract this portion. Whole circle is probability of H. From this whole circle, we will have to subtract this portion, isn't it? So okay, so what is this? Probability of H given W bar, that is given the wife will not vote, is equal to probability of H intersection W bar by probability of W bar. W bar is from P of W, we can easily find from P of W, we can easily find P of W bar. Now what is H intersection? H intersection W is from H we will minus this part, then we will get H intersection W. Okay. Now next, a town has 2 fire engines operating independently. Okay, it is independent events. The probability that a specific engine is available when needed is 0.96. Both the fire engines work independently. There is no dependency between them. So what is the probability that neither is available when needed? So first we will have to find out what is the probability that one is not available. Then what is the probability that the other one is not available, because there is independent events on when we try to find out when both is not available, it's just the multiplication of both the events, that's all, isn't it? When it is independent event, what is probability of A intersection B is probability of A into probability of B, right? So we have what is P of A, we have what is P of B, then from that we can find out A complement, B complement. It is just 1 minus P of A will give us 1 P of A complement, similarly P of B complement. So once we got that, to find out probability of A intersection A complement intersection B complement, it's just the product of these 2 events. Next, what is B? What is the probability that the fire engine is available when needed? See here, what is the probability that the fire engine is available when needed? That means fire engine is available when needed, that can be 1 engine may be available, 2 engine may be available, means either one is available or both is available. Okay, that means when I need a fire engine and there is one, that means either one is available or both are available. So what? That is A union B, probability of A union B. Then just put it in the formula. Cool, right? So draw the Venn diagram, write down the events. For all the case you don't need to write down the events, you write down the draw the Venn diagram of course, but events you will write for all the cases, and even if you draw the Venn diagram, then things becomes more clear. So, next, in a certain region of the country, it is known that from past experience that the probability of selecting an adult over 40 years of age with cancer is 0.05. Okay. So, what it is given, there is a probability of selecting an adult over 40 years of age with cancer is 0.05. If the probability of a doctor correctly diagnosing a person with cancer as having the disease is 0.78, that means the person has cancer and the doctor has diagnosed that he has cancer. That means given that the person has cancer, the doctor has diagnosed that he has cancer. Okay, conditional probability. And the other one is, and the probability of incorrectly diagnosing a person without cancer as having the disease. That means given that the person does not have cancer, but the doctor has diagnosed that he has cancer. Okay. So, now what is the question? What is the probability that an adult over 40 years of age is diagnosed as having cancer? So, this is clearly a question of what? Can you understand? So, it is a question of total probability, right. So, first we have drawn, we have written down the events. First is an adult selected has cancer, that is an adult over 40 years of age. I have just removed the age because age is just a redundant information here. This is not very important information here. Sometimes in some question you will see some very redundant information, means which are not very much required. So, unnecessary, we do not need to drag those while writing down the events, or sometimes we totally need to ignore some information. You see, some informations are just given so as to make the problems complicated. Like here, that adult is whatever age, it is immaterial in the questions basically. So, here event C is an adult selected has cancer and the D is the adult is diagnosed as having cancer. Now, what it is given, say first thing is given, probability of C is 0.05, adult over 40 years of age with cancer is 0.05, here it is given, here it is given, right. Next it is given, if the probability of a doctor correctly diagnoses a person with cancer as having the disease is 0.78, this is thing. This is the thing. The person given that the person has cancer and the doctor has diagnosed that he has cancer. Okay. And the other when C is 0.05, then probability of C bar is 0.95, 1 minus 0.05, right. And the other one, the next part you see, and the probability that incorrectly the person does not have cancer, but the doctor has diagnosed he has cancer. So, he is not a very good doctor maybe, or maybe he was not very much attentive at the time of reviewing the reports, right. So, this is J. So, we have all this information. Now, what we have to find out, what is the probability that an adult is diagnosed as having cancer. This is basically a question of total probability. But now, if I want to draw the diagram, basically I need to find out, this is my D, I need to find out what is the probability of this D, and what information I have. Say this is my universe of sample space, I have how many disjoint events here? 2 disjoint events. I have 2 disjoint events here. One is this portion, that is the person has cancer, and one is this portion, the person does not have cancer. Okay. This is the portion where person does not have cancer maybe, or this is the person, the person does not have cancer, and this D is the circle. In the D circle, all the person are diagnosed with cancer. So, some portion of the people who has cancer diagnosed with cancer, some portion of this thing who does not have cancer, but still diagnosed as having as cancer. Okay. So, now that means what we will do to find out probability of D is basically intersection of this part and this part. Intersection of what? Intersection of this with D, intersection of this with D, what we have seen yesterday. So, what is probability of D? Probability of D is the person has cancer, C intersection D plus C bar intersection D, that is the second part. So, this is C bar, and this is D. So, this portion is C intersection D and this portion is C bar intersection D. So, and we know what is this, we have the formula, we have the value for all this, just put it in a value and we will get the result, right. So, okay. So, now next question, if the probability is 0.1 that a person will make a mistake on his or her state income tax return, find the probability that 4 totally unrelated person each make a mistake. Now, is this a question of independent events, dependent events? Definitely it is a question of independent events, unrelated people. So, there cannot be any dependency. If one is making this mistake, means that does not mean the other will make any mistake, totally unrelated people. So, 4 totally unrelated person, it is just the unrelated people means it is just the multiplication of all the things. So, this is this, that cool. Then second is Mr. Jones and Miss Clark both make mistakes and Mr. Roberts and Mr. William do not make a mistake. 2% make mistake, 2% does not make mistake, out of the 4% may be, and there are 4%, out of this 4%, 2% make mistake, 2% does not make mistake. What is the probability of the not making mistake? It is just 1 minus of probability of making mistake, complementary event. So, again the, to compute B, again since all are independent events, just a multiplication of all these events. Okay. So, now the required probability is this, just the multiplication of this. 0.1 corresponds to making mistake, 0.9 corresponds to not making mistakes. Okay. Now, in a federal prison, it is known that 2/3 of the inmates are under 25 years of age. It is also known that 3/5 of the inmates are male and then 5/8 of the inmates are female or 25 years of age or older. What is the probability that the prisoner selected at random from this prison is female and at least 25 years old? Now, here age is not a redundant information, here age is necessary. Like in the last question for detecting cancer, the person is 40 years old and all, that was like an unnecessary information, but see here age is an important information. So, we just cannot ignore it. So, first what is given, we will see one by one. It is known that 2/3 of the inmates are under 25 years of age. So, this is one important information, 2/3 of the people are under 25 years of age. Okay. So, we will write a even corresponding to this. Next, it is also known that 3/5 of the inmates are male. So, male is 3/5, then what is female? 1 minus 3/5, because it is just a complementary event, right. And 2/3 of the inmates are under 25 years. So, what is the percentage of above 25 years? So, it will be 1 minus that, right. That is under 25 years, it is less than 25, not equal to 25. Then what is another information is here, the 5/8 of the inmates are female or 25 years of age or older. Here 5/8 are female or 25 years or older. Now, what we need to find out, probability that the prisoner selected at random from this prison is female and at least 25 years old. Now, write down the events. First, when you write down the events, things you will see it is very easy. First is, we will write that an inmate is a male and inmate is under 25 years of age. That is the first information that we had, and this was male was 3/5 and N was 2/3. Okay. Then again we had one more information, this 5/8, 5/8 of the inmates are female or 25 years of age. So, what is that? Female or 25, female. If male we are writing by M, then female we can write by M bar. Male we are denoting the male event, we are denoting by M, then female I am denoting by M bar. Okay. N is even I am using the I am denoting the inmate is under 25. So, N bar is an inmate which is 25 or above, just the complementary. So, my probability of M bar union N bar, it is given, it is 5/8. Okay. So, now what is the probability that the prisoner selected at random from this prison is female and at least 25 years, is female and at least 25 years or older. So, that means and that means I have to find intersection. So, what do I need to find? probability of M intersection N bar. M intersection N bar. M bar denotes female and N bar denotes inmate is 25 or above, at least 25 years old. At least 25 means 25 or above. So, what is this formula corresponds to? We have seen it before. Just put it a value and we will get it. So, any probability problem, always write the events properly. Clearly, if you write the events, you will be able to solve it, that I guarantee. And for total probability, always draw the Venn diagram. Which portion you have to find out, which total probability of what, and what are the disjoint events. Always specify the disjoint events, which disjoint in total probability what happened, the different disjoint events cover up the required probability, what, isn't it? So, now this required probability is nothing but a summation of all these disjoint events. So, once you do that and whatever value is given, you will be able to calculate it. So, problem is, if you could draw the Venn diagram properly, then it is done. Next, a producer of a certain type of electronic component ships to supplier in lots of 20. Okay. Suppose that 60% of all such lots contain no defective component, 30% contains one defective component and 10% contains two defective components. 60% of the lots contain no defective, 30% contain one defective component and 10% contain two defective components. Means out of 20, 60% is no defective. Again, other different lot means different categories, right? And again, in another lot, 30% contain one defective, and another lot 10% contains two defective. A lot is picked. Two components from the lot are randomly selected and tested, and neither is defective. Okay, two components from the lot are randomly selected and tested, and neither is defective. What is the probability that zero defective component exists in the lot? Two components are picked and both are found to be not defective. Now, what is the probability that it has come from that lot, okay, which has zero defective? So, this is a question of Bayes theorem. Fine. If I would have asked what is the probability that we are getting no defective component, then it is a question of total probability. Now, I have asked zero defect, we have two components from the lot we have selected and found that it is not defective. What is the probability that it has come from a particular one disjoint area? So, it is a question of Bayes theorem. So, now this is the lot with no defective component, no defective. Okay. And so, there are three different categories here. Three different disjoint categories here. What are the three disjoint components? One with zero defective, say this is one category which is where there is zero defective. Another, say it is what we have, say whatever event I have named, I forgot here. A 0 is it is say with one defective. Another, say it is T, say it is two defective. Okay, here it is two defective. Now, here what I found, I have picked two components from a lot, I have picked two components, I found both the components are not defective. So, what is the probability that I have picked from this lot, or means I need to find out the, when I found that both the components are not defective, what is the probability that I have picked this lot from this one where there is no defective component. Okay. So, first we will, for that first we will find out the total probability. Total probability is this one, this whole circle, maybe let me consider this whole circle as this. Okay, this I am, one second, this I am writing as n, then it is easier to differentiate. N is no defective, 0 is one defective, T for 2 is 2 defective, and this one with 2 defective component, with no defective I am writing as A, suppose this circle. So, what will be my probability of A? Probability of A will be what? Probability of n intersection A, probability of n intersection 0 means O, sorry, and probability of n intersection T. This is my probability of A. That is the total probability. Now, I am interested in finding out that my defect, if it is and I found that it is non-defective, what is the probability that I have picked it from this no defective component, right? Let me come back to this. So, these are the things which are given. Probability of n is 0.6, 0 is 0.3 and probability of t, that is contains two defective components, 0.1. So, these are the things given. What is the, see here, probability of A given n, what is this? Probability of A given n means, what is this? Means given that the lot contains no defective component, what is the probability that I have picked up two defective components? Fine. What is the probability that I have picked up two non-defective component? What is my A? A is two non-defective component. This, how will I find out what is the total sample space? Total sample space is from, I am picking out from 20 C2 is my total sample space, and out of this 20, when there is no defective components, how many defective? There is no defective component, right? So, all are non-defective components. So, that is from 20, again from non-defective components I am picking 2. So, this is my probability of A given n is 1. Probability of A given O, that both the components are not defective when I have picked it from the lot which has one defective component. So, if it is one defective component, you can see here it is given this one 19, from 19 I am picking 2, because one defective component that I am removing it. So, from 19 if I am picking 2, so this is my probability of A given O. Similarly, what is the probability of A given T? That is, there are two defective components. So, I am picking 2 from the rest 18. So, from 18 I am picking 2, that is 18 C2 divided by 20 C2. Okay, fine. Now, what I need to find out is probability of n given A. Given that two non-defective components are picked, what is the probability that I have picked from n, that is no defective component. This denominator is the total probability which I have just now I have shown in the whiteboard, right? Rather blackboard, which I have shown in the blackboard how we have calculated the total probability. This is the total probability. Probability of n given A, what is this? Probability of A given n, probability of A, that both the components are not defective, given that we have picked from the lot which are not defective, into probability of n. So, by this is the total probability, that is probability of A. This denominator is nothing but probability of A. So, now putting the formula, we will be getting it. Okay. Similarly, I can, next question, what is the probability that one defective exists in the lot? Same way. Then again, what is the probability that two defective exist in the lot? Same way, just probability of T given A. Okay. Next, this question. A certain federal agency employs 3 consulting firms A, B and C with probabilities of 0.40, 0.35 and 0.25 respectively. Okay. It employs 3 consulting firms. Each firm, the probabilities of each firm is given. And from past experience, it is known that probability of cost overrun for these firms are 0.05, 0.03 and 0.15. Each firm there is a cost overrun. So, each firm is used, first firm A is used 40% of the time, B is 35% of the time, C is 25% of the time. However, there is a cost overrun for A is 5%, cost overrun for B is 3%, cost overrun for C is how much? 1.5%, right? Sorry, 15%. Now, then suppose a cost overrun is experienced by the agency. What is the probability that a consulting firm involved with company C? Again, this is a question of Bayes theorem. Cost overrun is involved. So, this is maybe the cost overrun. Okay. So, maybe overrun, I can say it is, let me take it as O. Let me take it this even as O. Okay. So, then the universal sample space, there are 3, that is A, B and C. A is 0.40, B is 0.35, C is 0.25, and this portion, this intersection of A and O, this I have termed it as O, intersection of A and O is 0.05, intersection of B and O is 0.03, intersection of C and O is 0.15. Now we know the things. Now what is the probability that a consulting firm involved with company C? Just same as previous question. Okay. Say this information are given. So required probability is this. Denominator is the total probability. First calculate the total probability, and what is the what it is given, what is the probability that a consulting firm involved with company C. So we have calculated probability of O, that is the total probability. Now what is given O, what is the probability that it has cost overrun has happened because of the company C. Okay, that's all. There's one more problem, I think the last problem in this tutorial. So an individual has 3 different email accounts. Most of our messages, in fact 70% come into account 1, whereas 20% come into account 2 and remaining 10% into account 3. The particular person has 3 accounts. Okay. Of the message into account, only 1% has spam, account 1% of the mail are spam mail, whereas the corresponding percentage for account 2 and 3 are 2% and 5%. What is the probability that a randomly selected message is just spam? Again, what is the probability that a randomly selected message is spam? So this is a question of what? Total probability, not Bayes theorem. We just want to find out the circle, probability of this circle. Okay. So first let me write down the thing, what to say, events. So events I have written as AI, messages from A1 is from messages from account 1, A2 is message from account 2, A3 is message from account 3. So this is my circle is B, again this is A1, this is A2, this is A3, fine, A2. A1, A2 and A3, and what is this this intersection of A1 intersection of A1 and B, what is given? Intersection of A1 and B is 1%, intersection of A2 and B, how much it is given? A2 and B is given 2%, A3 and B is given 5%. This intersection is given. This whole A1 is how much given, whole A2 is given how much, whole A3 is given how much. So finding the total probability is easy, right? Isn't it? So that's it. Okay. So therefore in the long run, what we have got, 1.6% of this individual message will be in spam. So what, again, like in last tutorial I have suggested this, again I am suggesting you to solve as many problems as you can. Try to find out any book on probability. You will just Google, you will be getting many free online books. Just go and browse those books, you will get many problems, solve those problems. In many books the answers are also given. Don't directly see the answers, first solve it, then you try to see whether the answers are correct or not. By solving this, it will give you more confidence. With that I end this tutorial. So these are the references, okay, and thank you guys.